Looks like everybody's in their seat, so let's go ahead and get started. Welcome. It's sunny over here in California. Hope everything is going well whereabouts you are. Excited to see so many here on this workshop tonight. We won't be taking too much of your time. We're going to get right into it. We're going to get into the content. We're going to run through a few methods of using the distance formula, go through a practice problem, and then I'll have some additional resources and things I would like you guys to jump into following this quick workshop. But nonetheless, let's go ahead and get started. So in this workshop, again, we will explore the distance formula, which falls under the main topic of straight lines, which that also falls under the subject of mathematics. Now, equations, symbols, tables, and information on the various topics covered under mathematics can be referenced on pages 18 through 32 of the NCEES Supplied Reference Handbook 9.2 version for the computer-based testing. So what is the distance formula? The distance formula is a general restatement of the Pythagorean theorem and is used to find the distance between two given points, either on a line or in space. Now, the formula is given by this right here. D is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared, where D is the distance between the 2 points given by the coordinates x1 and y1 and x2, y2. Now, the distance can be expressed as unitless or in a provided unit coordinate system, such as feet or meters. It doesn't matter. Now, x1 and x2 are the x coordinates of the respective points, and y1 and y2 are the y coordinates of each respective point. Now, the distance formula itself can be referenced under straight lines on page 18 of the NCEES Supplied Reference Handbook. This again is 9.2 version for the computer-based testing. Now that we have established the general definition of the distance formula, let's discuss two common problem types that we may encounter on the FE exam. So the first problem type, we will be given the x and y coordinates of 2 points. We'll be given the x1, the y1, and the x2, y2. We'll just be given 2 points. In this case, it's just a simple plug and play. We put those points into the distance formula equation and we calculate it. There's not much work that needs to be done. However, there's a second scenario which is a little bit more complicated and takes a little bit more effort if you're going to manually move forward with calculating it. And that's when we are given the distance between 2 points. We're actually given the distance, and we're given 3 of the 4 xy coordinates, with one of those coordinates being unknown, and we're asked to solve for that unknown coordinate. So again, the first case is a simple plug and play scenario, but the second case requires calculations using the quadratic formula. Now, this approach, in the case that we use the quadratic formula, can be fairly time consuming, and it could open us up to multiple calculation errors as we make our way through our manual process. So in this calculator workshop, what we will do is we'll go over how we can solve for a problem that falls under that second scenario, where we have to find an unknown coordinate in a distance formula problem. And we'll do that using the TI-36X Pro, and we will compare that process against the typical manual approach using the quadratic equation. So now we know that in order to use the quadratic equation, the first thing that we must do is manipulate any given equation to ensure that it is in the standard quadratic form, which is ax squared plus by plus c is equal to 0. We've all seen this equation. This is the standard quadratic equation. Once it's in this position, or in this form, we can then define the values for a, b, and c. and plug them into the quadratic equation, which is x is equal to negative v plus or minus the square root of b squared minus 4ac divided by 2a. So again, this is a very familiar and comfortable formula that we've all seen throughout our time in the university as well as after. So we're very comfortable with making these calculations, and our first go-to is to probably solve these types of problems using this quadratic equation. But when it comes to time and efficiency on the exam, there's much faster ways, which I'll show you today. So again, the quadratic equation itself can be referenced under straight lines on page 18 of the NCEES Supplied Reference Handbook, again, version 9.2 for the computer-based testing. So now that we got all that definition out of the way, let's go ahead and jump into a typical problem we may see on the exam. So the problem states, given 2 points with the coordinates 30, -3, and a, 7, determine the value of a if the distance between the points is square root of 424. So we are going to walk through this problem first by going over how to solve it manually, and then we will run through how to solve it using your NCEES approved non-graphing calculator, specifically the TI-36X Pro. Now recall that this problem falls under the second problem type as described just previously in a few slides prior, where we are given the distance and 3 of the 4 xy coordinates of the 2 points. We are now asked to solve for that one unknown coordinate, which is a. So to be clear, in our end goal, this problem requires that we use the distance formula to set up an equation relating the given points and the distance between them so that we can solve for the value of the unknown coordinate a. So recall that the distance formula is d is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. Again, where d is the distance between the 2 points given by the coordinates that we are given. X or y1 and y2 are the y coordinates of the 2 points. And x1 and x2 are the x coordinates of the 2 points we are given. Now, in this problem, we are given the distance of the square root of 424. We're given the x1 coordinate, which is 30. We're given the y1 coordinate, which is -3. We're given the y2 coordinate, which is 7. But we don't know the x2 coordinate, which is given as a. So the first thing we need to do is plug these values into the distance formula. So doing that, we get the square root of 424 is equal to the square root of 7 minus -3 squared plus a minus 30 squared. So now that we have one equation and we have one unknown variable, which is a, we can now move forward with solving using one of the 2 methods we've already mentioned. So the first technique is to, again, simply solve by manually first expanding and simplifying the equation and then putting it into the standard form of a quadratic equation. We can then use the quadratic formula to solve for the unknown variable a. And then we got our second method, which is much more efficient, is way faster, and that's to use the equation solver function on your calculator, the TI-36X Pro. So what we're going to do now is actually walk through method 1, which is a very comfortable method for us. It's where we just manually do it. We can do this, we're trained to do it. But the name of the FE exam is to be most efficient. So if your calculator can do it, let's go ahead and train ourselves to know how we can do it on our calculator. So this is let's go through the manual equation solving. That's method 1. So starting with the distance equation we formulated with the given information, again, we have the equation as it's stated right there. Our second step is to simply just square each side to get rid of the square root. Not a big deal. The next step in step 3, we'll just go ahead and simplify. And then for step 4, we'll go ahead and use our FOIL technique to distribute the binomials. Recall that the letters FOIL stand for first, outer, inner, last. So first means you multiply the terms which occur first in each binomial. And then outer means you multiply the outermost terms in the product. Inner means multiply the innermost 2 terms. And last means multiply the terms which occur last in each binomial. Then finally, we simply take the product and combine any like terms which may occur. So following this technique, we're going to get what you see here on the screen. 424 is equal to 10 squared plus a large equation right there. So for step 5, we're going to go ahead and simplify that. In step 6, we're going to combine the like terms. And then in step 7, we're actually going to combine a little further. So the next step is we just need to rearrange and put this equation into the standard quadratic form. Again, the standard form is ax squared plus by plus c. So doing some quick math, we can go ahead and subtract 424 from each side, do all of our quick calculations, and we come up with 0 is equal to a squared minus 60a plus 576. So now that the equation is in standard form, we can now define our values for a, b, and c, which is obviously 1 for a, b is negative 60, and c is 576. So now that we have all of our a, b, and c terms, we can simply just refer to the quadratic equation, which you probably have memorized, and we just plug in our values. We go through a couple calculations. We know since the value of a is squared here in the standard form, we know that there's going to be 2 roots, so we can't forget that. So we just put our a, b, and c's into the quadratic formula. We solve for it, and we get 2 roots, one being the x1 root is 48, the x2 root is 12. Therefore, the 2 points that are a square root of 424 away from the point 30, negative 3 from our problem statement would be 48 and 7 and 12 and 7. So I just cruised through that problem really quick. You've already saw all the graphics were already here on the screen, but if we were to do this by hand, it would obviously take a little bit more time than me just illustrating it already done. So we obviously don't want to spend all of our time manually doing these equations and these formulas that can be done on our calculator. We have limited time on this exam. We only have 6 hours, 110 questions to get through. So when we come across a simple problem like the distance formula, we need to just take and use our calculator and use it to its best ability. So what I want to now show you is actually method 2, and that's using your NCEES approved TI-36X Pro calculator. So again, we're going to just start off with our standard equation. So in either method, we always have to formulate that distance formula first. So we have to have that information. Now, the next step, what we're going to do is actually initiate the numerical solver on our TI-36X Pro. So we're going to hit the second button, and we're going to locate the sine and inverse sine button, which you can see right above that. It says num, N-U-M, SOLV. So that's your numerical solver. That's how you initiate your numerical solver. Now, step 3, once you initiate that numerical solver, The screen will display two empty squares with an equal sign between them. Now you can enter the equation into the solver. And to simplify everything, I went ahead and just in my head, as we can all do, is we just squared both sides. We got rid of the square root. You can input that into the numerical solver if you want, but you don't need to because it's simple. It just makes it more simple. So the equation that we put in is 424 is equal to 7 minus -3 squared plus x minus 30 squared. Now, the TI-36X Pro doesn't have a, so for the variable, you hit the X button, which is on the left side of the calculator. And I'll be showing you here in a second a video of this process so you can see where all these buttons are located. But you hit that variable button, and you're also going to need to square some things. So you have to hit that X squared button, which is also on the calculator. Now, once you're complete, you hit that Enter button. This will submit the equation and bring you to a new screen. On this screen, we will need to provide a starting value of iterations for the equation solver to iterate through and search for a value that satisfies the inputted equation. Now, this screen should say something like enter and solve on one line, x is equal to some numerical value, and then the third line can be solve for x. So one thing I do want to note, again, there's going to be two roots for this equation, for this specific equation. So the calculator is only going to give you one root at a time. So in order to solve for multiple roots of an equation, we can iterate through intervals of 100 to ensure we are changing the starting points of the iteration process. So to start, we will scroll down to the line that says, where it says numerical value, and we're going to input the value of 0. We're going to scroll then down to the next line, solve x, and we're going to press enter. Now, depending on how far away the solution is from 0, it may take a few seconds for the calculation to complete and the next screen to load. But nonetheless, once it does load, the screen will read like this. The first line will say solution. Second line will be x is equal to 12. Third is going to be L minus R equals 0. And then the fourth line is going to be solve again or quit. So we now know that 12 is one of the values for our unknown coordinate A. Now, real quickly for everybody, here's a strategy for the exam, okay? We have one root. So a good test strategy at this point would be to give the choices, look at the options of the answers, see what answers are available for the problem, and just give them a quick glimpse. If any of those choices or answers do not contain 12 as an x coordinate, then we know we can eliminate that choice as an option. Maybe at this point, there will only be one option that has 12 as an x coordinate. In that case, that's the answer right there. And we don't have to move to iterating the next solution. So since we know there are two roots again for this equation as the x term is squared, we need to solve now for the second value of a. So at this point, the calculator will be blinking on the solve again at the bottom of the screen. So once you are ready to move forward with the next solution, just simply press enter. You'll be brought to the same screen as you were previously, where the first line will be step 4, sorry, where the first line will be enter and solve. The second will be x is equal some numerical value, and that's actually going to say x equals 0 because that's what you previously put in. And then the third line is going to be solve x. So this time around, you're going to put 100 in for the numerical value, switch down to solve, and push enter on solve x. So once you do that, you'll get another solution. And that solution this time should be x is equal to 48. So we now know that x equals 48 is the second value for our unknown coordinate A. Now at this point, we can evaluate our answer choices and look for the answer choices that define the 2 points that we've now determined. Again, those 2 points are going to be 48.7 and 12.7, exactly what we got previously using our manual process. So now what I want to do, we're 21 minutes now into this tutorial. I want to go to the next screen, and this is a video of me actually solving this problem. So it's going to show you kind of in real time how fast this can be done. So I obviously, for illustration purposes, took it nice and slow, but here's actually what it will look like. And that's it. I stepped through that really slowly so you could actually watch my fingers hit the buttons, but it's literally that fast. If we have an equation, we can define that variable within the numerical solver. We can then iterate from certain values of x and find the solution that fast. So that's going to conclude today's webinar review on the calculator tutorial on the distance formula. And what I want you guys to do next is actually hop over to the Prepineer Q&A forums, where we will be providing additional practice problems. We're actually going to put together a nice little packet for you guys to take away. We're going to provide you the step-by-step procedures to complete these types of problems as well. And then we're also going to create or initiate a conversation around the distance formula. So if you guys have any questions about this particular function on your calculator, the TI-36X Pro, go ahead and hop over there. Myself, Daniel, and all the other professional engineering mentors will be there to answer any questions you may have. So for now, that's it for today. Be looking out for the next calculator tutorial. We're always taking suggestions. Send any ideas of ones you may want to see in the future. Again, there's a couple tools that the NCEES gives to you on the exam, one being the calculator, two being the NCEES reference manual. If you end up becoming a master at both of these, the exam is going to become much, much easier. You're going to be solving things much more efficiently. You're not going to run out of time. So for now, I just want to say God bless. Have a great weekend. Thank you for taking some time out of your Friday to spend with me and watch me go through a calculator tutorial. And until we talk again, take care. Bye-bye.